All right, matrices are really useful for organizing certain kinds of information. I want to give you a couple of examples. Um, but just to review, a matrix is a systematic arrangement of numbers into rows and columns. I'm going to give you a really boring one here. 1, 2, 3, 4, 5, 6. Okay, so there are 2 rows in this matrix and 3 columns. Um, and what is interesting is that all of these numbers, for example, share a certain property, and that is that they're part of the first row. So just the structure of this organization itself contains useful information. Um, all these numbers are part of row 1. Likewise, for example, all of these numbers are in row or column 2. So just by being placed where they are, there's a certain amount of information contained there. So that might seem a little abstract. So let me give you a couple examples of situations in which we could organize data into a matrix. Okay, so for this one, I'm imagining maybe some kind of experiment where you're looking at the effect of some aspect of the environment on the growth of different kinds of plant species. Okay, so I mean, I just made up all these numbers, but this, it's a semi-realistic situation. Um, so, for example, site 1, species 1, 32 centimeters. So I'm imagining something like um, I pick a certain site, I don't know, maybe like a semi-shaded forest or something, and I'm looking at the first plant species that I decided to study, and I'm recording how its maximum growth after a month or something. Okay? Site 1, species 2, 30 centimeters, site 1, species 3. So I've got 3 different plant species all at the same site. So here's a piece of information that they all share. Kind of like it's kind of like that I just drew over my matrix, or my soon-to-be matrix. But you see this point? This is a piece of information that all 3 data points here share. So instead of writing it over 3 times, I could be a little bit more elegant with that. Um, okay, so I'll do that in a second. Site 2, species 1, 18 centimeters. So I'm I'm these 2 data points have something in common in that they're both about the same plant species. Uh, Similarly, these 2 data points, let me switch colors, um, have something in common. They're both about plant species number 2. So instead of this kind of repetition, what I could do is I could reorganize this thing into a simple matrix, like so. Um, it would look like this: 32, 30, 28, 18. That, I don't know what number that was. Definitely didn't look like an 8. 18, 21, 17. Okay? Where the rows represent the sites. So all these values have to do with site number 1. Um, all the numbers in row 2 have to do with site number 2. Okay, so what does this represent? What does this column represent? So 32 and 18. They're both about species number 1. 30, 21. These are both about species number 2. So my columns um, are species, and my rows are site numbers. So now that I know that, um, all this information is sort of contained in the structure of this. So I look at this point. Well, it's in the second row, so this observation is for site number 2, and it's in the third column. So this is about species number 3, the third plant species, right? That information is contained just in where it's located in the matrix. Let's look at this one. What is this observation for? Is it 30 centimeters? Well, what's 30 centimeters? Well, it's in row 1, so it's at site 1, and it's the second column, so it's the second plant species. So the basic idea is if you have lots of repetition and ways in which numbers are related to each other, it could be more economical or simple or more elegant to organize it as a matrix. So let me do a similar thing with this data set. So I've got Jupiter surface temp number 1, 164 degrees Kelvin. Jupiter again surface temp number 2. So maybe we're observing Jupiter and we're measuring the temperature of its surface in different spots, just to, I don't know, maybe we want to see if it's cooler in its north and south pole, and if it's warmer in its equator, or I don't know, maybe we're tracking a storm or something on Jupiter. I don't know. I'm making this up. So, but the point is that these values all relate to the same thing, Jupiter. So we're taking 4 different readings of its the temperature of its surface, maybe in different spots or something, and all 4 readings have to do with Jupiter. Then we've got the same thing, but with Saturn, and maybe we chose 4 different points for each planet. Maybe the North Pole, South Pole, it's equator, but towards the east, or something like that. We're picking 4 different spots that we think might be interesting, and we're going to do that for each planet. So all these values relate to Jupiter, all these values relate to Saturn, and then these temperature 1 and temperature 1 relate. So what we can do is we can organize that as a matrix. Let's choose a cool color. I don't know, yellow. Let's do pink. I don't know, just something different. So what we'll do is the first row will be about Jupiter, and the second row will be about Saturn, and then the first column will be temperature 1, second column temperature 2, third column temperature 3, fourth column temperature 4. So we've got 164 Kelvin, 165, 170, and what's the fourth one? 163. And then we're going to do the values for Saturn, 134. Sorry about that, 3. Wow, I did it again. Kind of looks like an ant or something. I don't know. This program interprets my 3's in a very strange way, pretty consistently. So, anyway, here's a matrix that rewrites this data in that organized form. So there's lots of situations in which it could be useful to organize data this way. And then once it's in a matrix, you can do all kinds of matrix operations, and that gets fun. So, all right. See you later.